Good evening, Ramchand. Today I would like to explain module 11, that is called machine learning. These are the core and mandatory concepts of machine learning. Machine learning is nothing but learning from the observational data.
Sir, actually, day before yesterday we started this. I think you have to continue from where you left, sir.
No, this syllabus is different. Look, I will
Okay,
explain.
okay, 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 sir.
So, learning from the observational data by applying supervised learning, unsupervised learning, and reinforcement learning. So these are the top 10 major concepts of machine learning. And uh, if you want to see the syllabus of machine learning, three parts I am dividing. One is supervised learning. Supervised learning is nothing but learning from the observational data based on the label data, based on the target class, and we are classifying the data based on the rule, and we are classifying the data. So that is called supervised learning. There are top 10 rules of supervised learning like linear regression, logistic regression, decision tree, random forest, support vector machine, SVM, and k nearest neighbor, and naive based classification, gradient boosting, GBM and XGBoost, and light GBM and cat boost, artificial neural networks, that is called ANNs, then ridge and lasso regression. Under unsupervised learning, what is meant by unsupervised learning? There is no target class, there is no label, but I would like to classify the data based on the similarity measure. How do we can calculate similarity measure? By using Euclidean distance, Manhattan distance, and Minkowski distance. And if you have 2 points like x1, x2, y1, y2, there is a formula called Euclidean distance, square root of x1 minus x2 whole square plus y1 minus y2 whole square. So these are the top 10 algorithms of unsupervised learning, that is k-means clustering, hierarchical clustering, DB scan clustering. Example, density based spatial clustering of applications with noise, and Gaussian mixture models like GMM, principal component analysis PCA, independent component analysis ICA, autoencoder, self-organizing maps SOMs, a priori algorithm for association rule mining, T distributed stochastic neighbor embedding, that is TSNE. Then reinforcement learning is nothing but learning from the observational data based on the punishment and reward, we are solving the problems. So especially in gaming applications, we are using top 10 algorithms of reinforcement learning like Q learning, deep Q networks, that is called DQN, SARSA. SARSA is nothing but state action. You can call it as state action, reward state action, that is called SARSA, policy gradient methods, actor critic A to C and A3C, advantage actor critic, proximal policy optimization, that is called PPO, trust region policy optimization, that is called TRPO, Monte Carlo methods, deep deterministic policy gradient, DDPG, the soft actor critic, that is called SAC. See, these techniques I haven't explained last class. Can you see the difference between last class and this class, Ramchan? These are
Yes, sir.
the
Yes, sir.
major concept of machine learning. I have prepared yesterday only because of some university meeting. I forgot actually.
Okay, sir.
Okay, now you need to learn all these concepts, syllabus. Now I
Sure.
am going to explain theory part of 10 topics in machine learning, very mandatory. You need to be thorough. Wherever,
Okay, sir.
whenever they are asking, you need to be explained like a gem.
Okay, sir.
Definition
Okay,
and
sir.
scope of machine learning. Machine learning is a subset of artificial intelligence. What is meant by artificial intelligence? Intelligent behavior in a machine, or science and engineering to develop intelligent based kind of applications that enables systems to learn patterns. What is meant by patterns? Pattern is a model. What is model? Model is a simplified version of the reality.
Reality.
Suppose every week you are going to purchase tomato, beans in the grocery shop every week or in market. What manager is observing, so and so candidate, so and so ID number, every week he is purchasing milk, bread, beans, tomato, so he is increasing his business. Are you understanding what I am saying?
Yes,
That
sir.
means
Yes.
it is a pattern. He is identifying your pattern based on your behavior. So, by using machine learning algorithms, it can learn patterns from data and make predictions or decisions without being explicitly programmed. If see, every day what you are doing, how you are behaving, every week are you coming to shop. So if I open your browser, automatically your history will be appeared, and based on that history I can say what type of person you are, like that. Okay. So, types of machine learning, there are three types of machine learning approaches we are using. Ramchan, how you can
Yes, sir.
define machine learning? Can you define your own sentence of machine learning? Learning from the observational data
Data. Yes,
with
sir.
the help of supervised learning,
Supervised learning,
unsupervised learning, and
supervised learning,
reinforcement learning. That
reinforcement
is a
learning.
beautiful definition.
Yes, sir.
Or simply you can say machine learning is a subset of artificial intelligence that enables systems to learn patterns from data and make predictions or decisions without being explicitly programmed. So here types of machine learning, supervised learning is nothing but uses labeled data. I have already explained. There is a label,
Yes, sir.
uses labeled data or target class to train models for tasks like classification and regression. Okay. What
Yes,
is
sir.
meant by classification? Based on the label, we are classifying the data. Based on the target class, we are classifying the data. Same as regression. We are predicting the past, we are predicting the future value based on the past values. That is called regression. We have three types of regression techniques: linear regression, non-linear regression, logistic regression. In classification, we have n number of algorithms that I am going to list out. Specifically, support vector machine, random forest, ADA boost, Bayesian networks, decision tree, neural networks, etc. Unsupervised learning is nothing but it identifies patterns. Simply you can say there is no label, there is no target class, but I would like to classify the data based on the similarity measure. Here, unsupervised learning identifies patterns and structures in unlabeled data such as clustering and dimensionality reduction, etc. What is meant by clustering? Clustering is a unstructured clustering is a group of objects, that objects having similar behavior, collection of data points, that data points having similarity measure, like a grouping of objects having similar behavior, that is called clustering. So, under dimension clustering techniques like k-means clustering, fuzzy c-means clustering, db scan clustering, agglomerative clustering, density based clustering, etc. Whereas dimensionality reduction is nothing but what is meant by dimension, Ramchan? Attribute.
Dimension is having
Attribute.
multiple columns of data.
Ah, perfect. It is a column. It is a attribute. You can say like that.
Okay.
It is a column.
Column.
Student is a table name. Columns
Yeah.
are name, ID,
Age,
roll number,
subject ID. Yeah.
email ID, mobile number, like that.
Well, yeah.
Perfect. So, dimensionality reduction means we are reducing the dimensionality by applying principal component analysis, k nearest neighbor algorithm, etc. Especially in face recognition application, we are using PCA technique. In face recognition, how they are finding matching between a new image to existing images. So there they are applying a PCA technique, principal component analysis. What it does, in your face, it will extract features like forehead distance, moles on the face, the distance between nose and mouth, the distance between chin to mouth, etc. If you increase number of constraints, 100% accuracy will come. That is called dimensionality reduction. So redundant portion we are eliminating in that dimensionality reduction. We are keeping all the images in orthogonal components. Redundant particles we are removing, especially in a face recognition application. We are using principal component analysis. Then reinforcement learning is nothing but trains agents through rewards and penalties to optimize the sequential decision making tasks. That means based on the punishment and rewards we are solving the problems is called reinforcement learning, especially in gaming applications. Are you understanding what I am saying, Ramchand?
Yes, sir, very much.
Then applications of machine learning. Machine learning is widely used in fields such as healthcare applications, especially disease prediction. Now I am doing a research paper on viral disease prediction.
Okay, sir, great.
I am so much interested on this disease prediction. I am writing research proposal to Australian government. I am requesting for fund proposal.
Sir, you
Then
can also
finance.
do MBBS, sir.
Sorry.
You can also do MBBS.
Why? No, it's very tough. It's very
Yes, sir,
tough.
please. Yeah.
It's a healthcare apply. Our part is we are collecting the images from the doctors. That's all.
Yes,
Then we
sir.
will do our pre-processing techniques. Then we can choose best models of supervised, unsupervised, and reinforcement learning. Then we are predicting detection of which virus disease of this image, CT scan image or X-ray image, etc.
Okay, sir.
You might have seen my profile, my all the papers and related to healthcare domain only. I
Yes, sir.
had
Yes, sir.
seen. Okay.
Yes,
Then
sir.
finance related fraud detection, especially in cyber security applications. We are I have done 2 3 papers on cyber security, and I have given corporate trainings on cyber security on 13 topics. After
Oh,
this
great, sir.
training I will train you on cyber security for free of cost, don't worry.
Oh,
Okay,
thank you, sir.
that
Thank
is
you, sir.
very good subject because that is more apt for your domain because you are interested in networking side, na? That is the
Yes, sir.
reason
Yes,
I
sir.
am saying. It's okay. But if you know data science, data mining, and AI, machine and deep learning, you will do wonders in cyber security for finding the fraud detection. So many applications. Autonomous vehicles like Tesla, they are using autonomous vehicles. You know,
Sir,
so
1 minute, sir. Can I just pass the meeting because I'm getting a call? I'll
yeah,
just
yeah, sure,
respond and
sure. Yeah, I'll
just
wait. No
1 minute.
problem. Yeah, yeah,
Yeah,
no
yes, sir.
problem. No problem.
இதுல இருக்கேன்பா கிளாஸ்ல இருக்கேன். ஓகே ஓகே.
Are you ready, Ramchan? Hello, Ramchan.
Yes, sir.
Are you ready, Ramchand? No problem. Can I start
Yes.
now?
Yes, sir. Yes, sir. Please.
If anyone joins, please allow them. No problem.
Yeah, sure, sir.
Okay, then we have applications of machine learning, autonomous vehicles, self-driving cars, especially Tesla. Elon Musk, he started one center at Bangalore. They are training on autonomous vehicles and recommendation engines, especially in Flipkart, Amazon, personalized content suggestion. We are using machine learning concepts. Now, next, how do machine learning algorithms work? What is algorithm? Algorithm is a step-by-step procedure to solve a particular program. It is a sequence of steps. Machine learning algorithms utilizes a variety of techniques to handle large amounts of complex data to make decisions. That's why we are using a machine learning algorithms. These algorithms complete the task of learning from data with specific inputs given to the machine. Yes, after pre-processing only, we are giving input to the system. Why? Raw material cannot be processed properly. If you give wrong input as input, you will get wrong output. Once you are doing pre-processing, then it becomes information that we can consider as a input given to the machine. Then it can give the correct output. So the process of machine learning algorithm was training. 80% of data we are training, and model creation we are doing. Then by using supervised, unsupervised and reinforcement in creation, then we are predicting the output. Then we are doing analysis which method is best, and retraining if it is not giving correct output again. Then we are predicting is the cycle of machine learning algorithm. This is the steps of how machine learning algorithms are working. This enables the machine learning algorithm to learn on its own. It produces optimal answer that will gradually increase in accuracy over time. How do you can calculate accuracy? The number of items are correctly classified by total number of items multiplied by 100. If you do, you will get accuracy. That's why we are using confusion matrix. Confusion matrix is a validation metric. It shows us how many number of items are correctly classified, how many items are wrongly classified. Based on that information, confusion matrix gives us the total number of correctly classified items by total number of items multiplied by 100. We are getting accuracy of over a certain period. These are the techniques we have seen already: unsupervised, supervised, and reinforcement learning. Supervised, again, we have classification and regression. Unsupervised learning, we have clustering and dimensionality reduction. So many techniques of each techniques. If you take classification, naive Bayes, support vector machine, nearest neighbor, etc. In regression, we have linear regression, logistic regression, non-linear regression, decision tree, etc. Dimensionality reduction, just now I have explained: principal component analysis, feature selection, linear discriminant analysis, that is called LDA. Under clustering, we have k-means, k-medoids, mean shift, etc. So this machine learning is a subfield of artificial intelligence. The goal of machine learning generally is to understand the structure of data and fit that data into models that can be understood and utilized by people. So we have ordinary system, and with AI we are selecting. Machine learning, we are choosing the model, then it learns, it predicts, and it improves. So these are the machine learning in a nutshell. We have types of learning. Yes, we have unsupervised learning, reinforcement learning, supervised learning, that is called regression and classification. Real world application, we have why we are using machine learning. We have self-driving car, chatbot, movie recommendation, spam detection in Gmail, diagnostics, etc. Then the process of applied machine learning algorithm, we have data cleansing or exploration, feature engineering, outlier treatment, missing value treatment, and data modeling, model validation, model evaluation, model deployment. How do you practice machine learning? Join communities, learn from experts, participate Kaggle contents, listen to podcasts, subscribe to new newsletter, and learn toolbo. So there again we have Python. Under Python we have n number of libraries like Keras, TensorFlow, Scikit-learn, Pandas, NumPy, etc. Under R program we have MLR, DPLYR, Caret, etc. Then theory we need to understand what are the multivariate calculus in under machine learning, what are the algorithm and complexity under machine learning? What is optimization under machine learning? What is probability theory and statistics and linear algebra? So this is about machine learning. We divided already three types. I have already explained supervised learning. The algorithm learns the relationship between specific inputs and outputs based on training data and human feedback. We have two number of supervised learnings, regression and classification. Unsupervised learning is nothing but the algorithm analyzes the data for trends and patterns without being given a specific output variable or human feedback. That is called clustering, dimension reduction, etc. What is meant by reinforcement learning? The algorithm learns over time to maximize returns based on the rewards it receives uh, for performing creation actions, and we have a model free and a model based algorithm. Okay, and machine learning is important because it gives enterprises a view of trends in customer behavior and business operational patterns, as well as supports the development of new products. We have a machine learning is very important. It is a computer programs that leverage is nothing but integrate algorithms and statistical models to learn through inference and patterns without being explicitly programmed. That's why machine learning is a learning from the observational data by applying supervised learning, unsupervised learning, and reinforcement learning. So, types of machine learning we have three types. Supervised learning is nothing but all data is labeled and the algorithms learn to predict the output from the input data. That is called task driven. Keep in mind. Supervised learning is nothing but task driven. Unsupervised learning is nothing but there is no label, there is no target class, but I would like to classify the data based on the similarity measure. All data is unlabeled and the algorithms learn to inherent structure from the input data. That is called data driven. Reinforcement learning is nothing but it works on interacting with the environment, whereas the supervised learning method works on given sample data or example, that is learning from errors. I have already explained reinforcement learning is nothing but based on the punishment and reward we are solving the problem. That is called learning from the observations, learning from errors. Simply you can say supervised learning Ramchan. It is a task driven based on the label. Unsupervised learning data driven based on the
Yes.
data. We don't know what type of label, what type of target class. Then reinforcement learning from errors. Then types of machine learning you know already. Supervised learning comes under task driven. Unsupervised learning comes under data driven. Reinforcement learning comes under learn from errors. Then machine learning process it takes training data 80% of big data sets like Facebook data, Orkut data, WhatsApp data, YouTube data, audio data, video data, text data, graphics, NASA data, traffic data, weather forecasting data we are taking as a big data. Then we are training of that data set into 80% of data. Then we are choosing the big model like suppose supervised learning model, unsupervised learning model, or reinforcement learning model. Then we are taking the decision. If it is not giving correct answer, again we are asking query. Then again we are performing training and testing and validation. Then application gives us feedback. This model has to be trained once again. Machine learning is the process of making systems that learn and improves by themselves by being specifically programmed. The ultimate goal of machine learning is to design algorithms that automatically help a system gather data and use that data to learn more. If we see the life cycle, first we are gathering the data, that is called data gathering, then data preparation, data wrangling, then data analysis, model training, model testing, and deployment. We are performing all these seven steps. Then how machine learning works? We are taking input data, then analyze data, then find patterns, prediction, it stores the feedback. Machine learning is a form of artificial intelligence that teaches computers to think in a similar way to how humans do, learning and improving upon past experiences. Based on the previous experience, we are performing current work. It works by exploring data and identifying patterns and involves minimal human intervention. That is called machine learning. What are the best examples of machine learning examples? Self-driving cars, credit worthiness, predicting an illness, computer vision. CV means computer vision in agriculture. Computer vision means audio, video, text, graphics, animation. Then ranking on social media, targeted emails, Q and based platforms, fashion industry, etc. Machine learning algorithm would be trained with pictures of dogs and other things, all labeled by humans, and the machine would learn ways to identify pictures of dogs on its own. That is called machine learning process. Then a second topic, mathematical foundation for machine learning. What is the mathematical knowledge you require to solve a machine learning algorithms? Yes, we need to have three concepts like linear algebra. It includes vectors, matrices, and eigenvalues. So, these are the linear algebra concepts. It provides the foundation for representing and manipulating data in machine learning models using concepts like vectors, matrices, and eigenvalues to optimize computations. Then second mathematical foundation for machine learning is probability and statistics. Here Bayes theorem and Gaussian distribution we are using. Probability and statistics help in modeling uncertainty with Bayes theorem, aiding in decision making, and Gaussian distribution being crucial for understanding data distributions. That is called probability and statistics. Third one, optimization techniques like gradient descent, convex optimization, etc. Optimization techniques like gradient descent and convex optimization are used to minimize error functions and improve model performance by adjusting parameters efficiently. Then supervised learning is nothing but linear regression, logistic regression. Linear regression predicts continuous values based on input features, while logistic regression is used for binary classification by estimating probabilities. We are going to solve these problems in machine learning. Then decision trees and random forest. These decision tree and random forest are the supervised learning concepts, algorithms. Decision trees split data based on features values to make predictions, while random forest improves accuracy by combining multiple decision trees for better generalization. What is meant by support vector machines? Support vector machine finds on an optimal hyperplane to separate data points into different classes, maximizing the margin between them for effective classification. Neural networks is nothing but ANN Artificial neural networks mimic the human brain's functioning by using layers of interconnected nodes to learn complex patterns and relationships in dataset. Then fourth concept, unsupervised learning. Cluster unsupervised learning, you know already. I have explained. There is no label, there is no target class, but I would like to classify the data. And there are four techniques we are using under this one. For popular techniques like K means hierarchical clustering, DB scan clustering, C means clustering. Clustering groups similar data points. What is meant by clustering? Clustering groups similar data points together, where K means partitions data into K clusters. Assumptions. K means, so I need only two clusters, you can define K. I need three clusters, you can define K is equal to 3, like that. Hierarchical clustering forms a tree-like structure, and DB scan identifies clusters based on density we are identifying. Then principal component analysis is nothing but PCA, principal component analysis, dimensionality reduction. PCA reduces the number of features by transforming data into a smaller set of principal components, while retaining the most important information. Association rule learning is nothing but a priori and FP growth. A priori and FP growth algorithms identify relationship between variables in large data sets commonly used in market basket analysis for discovering frequent item sets and association rules. Then deep learning, and we have deep learning basic concepts in machine learning. Deep learning is an extension of machine learning. Deep learning is nothing but learning from the observational data by using similarity measure. Okay. Then we have fundamentals of deep learning networks, like deep neural networks consists of multiple layers of interconnected neurons that learn complex patterns from large data sets through back propagation and optimization techniques. That is called deep learning techniques. Convolutional neural networks, that is called CNNs, for image processing, that is called convolutional neural networks, are specialized neural networks designed for image and spatial data processing using convolutional layers to detect patterns like edges, textures, and objects in images. Recurrent neural networks like RNNs for sequential data. RNNs are designed for sequential data processing such as time series data and natural language by maintaining hidden states to capture dependencies between previous and current inputs. What is meant by transformer models and attention mechanism? This is a special concept in deep learning. Transformer models like machine learning, deep learning, like transformer models powered by self-attention mechanisms, efficiently process sequential data in particular, and we are widely used in NLP applications like BERT and GPT for text understanding and generation. That is called transformer models and attention mechanism. Feature engineering and processing. That means data pre-processing. Feature engineering is nothing but we are extracting features from the data set, like handling missing data. Suppose missing data can be managed using techniques such as imputation, like mean, mode, median, deletion, or predictive modeling to ensure the data set remains complete and reliable. Feature scaling and normalization is nothing but scaling means we are checking 10 to 20 one scaling, 10 to 30 one scaling, like scaling techniques like min max, minimum value and maximum value. Scaling and standardization ensure that numerical features are within a similar range, improving the performance and convergence of machine learning models, etc. Encoding categorical data is nothing but categorical variables are transformed data uh, into numerical form using encoding methods like one hot encoding, label encoding, or target encoding to make them suitable for machine learning algorithms. Then the last one, feature selection techniques. We have n number of feature selection techniques like recursive feature elimination, that is RFE, mutual information and principal component analysis PCA help identifying the most relevant features to enhance model efficiency and accuracy. What is mean by 7th concept is model evaluation and validation metrics. So, model means simplified version of the reality. Whatever you are developing supervised learning technique, unsupervised learning technique, and reinforcement learning technique. We have validation metrics like confusion matrix, precision, recall, F1 score. Try to listen carefully. Based on this validation metrics, we are justifying our model is correct or not. The confusion matrix provides insights into model performance by dealing true positive, false negatives, and true negatives, while precision, recall, and F1 score measures the accuracy and balance between false positive and false negative. Then what is meant by ROC curve and AUC curve? The receiver operating characteristic. ROC means receiver operating characteristic curve illustrates the trade-off between sensitivity and specificity, with the area under the curve AUC representing the model's overall ability to distinguish between classes, cross validation, bias variance trade-off, etc. Cross validation techniques such as a k-fold cross validation help evaluate model performance on different data subsets, while understanding the bias variance trade-off ensures an optimal balance between underfitting and overfitting. So once we are performing any operations on our data set, so based on the data set, you need to classify 80% of training and 20% of testing. Within that constraints, we are performing and we are solving the problem that is called underfitting. If the problem is not beyond our input, beyond our techniques we are applying, that is called overfitting. Hyperparameter tuning is nothing but fine tuning parameters like grid search, random search. So hyperparameter tuning methods like grid search and random search optimize model parameters to improve accuracy and generalization on unseen data. Then what are the ensembling learning methods under machine learning techniques? We have ensemble learning techniques like bagging and boosting. Those are the ADA boost, gradient boosting, and XGBoost. Bagging reduces variance by training multiple models in parallel, while boosting sequentially corrects errors by focusing on misclassified instances, with algorithms like ADA boost, gradient boosting, and XGBoost enhancing model performance. Stacking and blending techniques. So it is one of the ensembled learning technique. Stacking and blending combine predictions from multiple models using meta learners, where stacking employs a secondary model to learn optimal combinations, and blending uses weighted averaging for improved accuracy. AutoML and automated feature engineering is nothing but AutoML automates the end-to-end process of model selection, hyperparameter tuning, and feature engineering, making machine learning more accessible and efficient for non-experts. Last but one concept in theory part of machine learning, reinforcement learning is nothing but learning from the observational data by applying punishment and reward. We are solving the problems is called reinforcement learning, especially in gaming applications. Markov decision process, that is MDP, is a one of the mathematical framework for decision making in environments with stochastic outcomes, where an agent learns optimal actions based on states and rewards and transition. Then what about Q learning and deep Q networks, that is called DQN. So Q learning is a value based reinforcement learning algorithm that updates Q values for optimal policy selection, while deep Q networks, that is called DQN, leverage neural networks to approximate Q values for complex environments. Policy gradient methods is nothing but optimize policies directly by adjusting model parameters to maximize cumulative rewards and making them effective for a high dimensional and continuous action spaces. Then the last, then the last topic under applications for machine learning, we have fantastic applications like natural language processing NLP applications. Under this broad domain, we have NLP enables machines to understand, process, and generate a human language, powering applications like chatbots, sentiment analysis, and machine translation. Then computer vision and image recognition. So these machine learning models in computer vision allow automated image classification, object detection, facial recognition, and medical image analysis. Next, computer vision nothing but audio, video, graphics, animation, and kind of that combination we can call it as a computer vision. Then fraud detection and financial modeling. Machine learning algorithms analyze transaction patterns to detect and anomalies and prevent fraudulent activities in banking, insurance, and e-commerce. Healthcare and predictive analytics. Machine learning powered predictive analytics helps in early disease detection, personalized treatment recommendation, and medical diagnosis based on patient data. So, with this one, we are completing theory part. Then we are moving to supervised learning, learning from the observational data based on the target class, based on the label. We are classifying the data. The top 10 algorithms of supervised learning. Yes, linear regression, logistic regression, decision trees, random forest, support vector machine, k nearest neighbors, naive Bayes, gradient boosting, GBM, XGBoost, light GBM, cat cat boost, etc. Artificial neural networks, that is ANN, ridge and lasso regression. Under supervised learning, we have classification and regression. So, classification regression means predicting a continuous variable. Example like predicting the price of a house based on its feature like size and location. Okay. Then classification, categorizing data into predefined classes. Example spam email detection. Simple linear regression, like you can call it as this description I am removing, no need of. So you can take it as spam email detection. Simple linear regression fits a straight line, that is y is equal to mx plus c. Ramchan.
Yes, sir. Y is equal to mx plus c. Yes, sir.
Perfect,
I
perfect.
recall.
That is called straight line, two data points. Example, predicting a student's score based on study hours. We have solved some problems. Multiple linear regression extends similar linear regression to consider multiple features. Example, predicting car mileage based on engine size, weight, and fuel type. Then ridge regression, time complexity of the model by adding a penalty term, like predicting house prices while avoiding overfitting. Lo- Logistic regression is nothing but used for binary classification problems. Then predicting if a tumor is malignant or benign. Then k nearest neighbor is nothing but it classifies a data point based on how its neighbors are classified. Then recommending a movie based on user preferences. Naive based classifier is nothing but assumes feature independence and uses Bayes theorem. Example, text classification for spam filter. Then linear discriminant analysis, that is called LDA. LDA is used for dimensionality reduction or classification. Example, like classifying wine types based on features like acidity and sugar content. Super vector support vector machine finds the hyperplane that best divides a data set into classes. Example, classifying whether a person will default on a loan or not. Decision trees uses a tree-like graph to make decisions. Example, predicting the likelihood of a customer buying a product. Then bias variance is nothing but it is a model, supervised learning model with the bias oversampling whereas high variance over complicates. Example, a linear model might underfit complex data whereas a high degree polynomial might overfit. What is meant by cross validation methods like leave one out and k-folds techniques to train and validate a model. Example, in k-folds, dividing the data set into k subsets and rotating them for validation. Multi-layer perceptron and feed-forward neural networks is nothing but a artificial neural networks for complex problems, handwritten digit recognition. Then these are the top 10 supervised learning like linear regression. It is used for regression tasks to predict continuous values. Logistic regression, it is used for binary classification problems for estimating probabilities. Support vector machine, it is effective for a high dimensional spaces and binary multi-class classification. Decision trees is nothing but it splits data based on feature values to create a tree for classification or regression. Then random forest is an ensemble method for combining multiple decision trees to improve performance. Gradient boosting mechanism is nothing but XGBoost and light GBM, gradient boost method. Powerful ensemble models using sequential decision trees to minimize errors. And what is meant by naive Bayes algorithm? Bayes theorem ideal for text classification and spam detection. K nearest neighbor classifies data based on their proximity to under neighbors in a future space. Linear discriminant analysis LDA. It projects data to maximize class separately for classification tasks. Multi-layer perceptron is nothing but a type of feed-forward neural network for regression and classification. Elastic net regression is nothing but combines L1 and L2 organization for linear regression. Ridge detection is nothing but refined regression with regularization to prevent overfitting. Lasso regression is nothing but linear regression with regularization to enforce sparsity in features. So can I stop here, Ramchand? Tomorrow we'll
Yes, sir.
start
Yes.
unsupervised learning and reinforcement learning with practical sessions. Is it
Yes,
okay?
sir. Yes, sir. Yes, yes, yes.
Okay.